Okay, let's see what we can do. We're on number 3, and now we are justifying whether the limit exists. And if it doesn't exist, we're going to use a table or a graph or whatever we want to do to justify it, okay? You can't just say, hey, limit doesn't exist because I feel like it doesn't exist. So let's look at this first one. So in this first one, we got this. I'm just kind of seeing what's going on here. Okay, so making sure it looks like we are approaching pi from the right. Okay, so if we were to look at this, right, if I were to look at the numerator, I think you'd agree, the limit as x approaches pi from the right of 9 is just 9. So the numerator is just going to be 9, okay? So it's going to be a constant. That's fine. What about the denominator? Well, I think you guys would agree. The limit, sine of pi is 0. So there's absolutely something going on here. It's a vertical asymptote. There's no way to cancel that vertical asymptote. So at this point, I've got a couple choices. I can make a table, and that's probably, that's probably what a lot of you are going to want to do. So pi, right? Pi is 3.14159, right? So maybe I choose 3.14, 3.101, whatever I'm choosing. I'm choosing numbers that are getting closer to pi from the left and to the right. I could absolutely do that. Well, actually, in this case, I'll be choosing numbers that are approaching pi from the right, so a little bit bigger than pi, right? So that's fine. Absolutely, you can go and do that. But I want you to also notice, I could also just think about this for a second. So this is a unit circle. Pi is right here, right? So we are approaching, we're approaching the sine of pi, but we're approaching it from the right. So we're approaching it from quadrant 3, right? Would you guys agree with me that any number plugged in to this function or into the, let's just talk about the sine function. Anytime I evaluate sine at any number in quadrant 3, which is exactly what I'm going to do, any number that's larger than pi is going to be in quadrant 3, right, as I approach pi from the right, is going to be negative. So I'm going to say, right, this is going to be a positive divided by a negative, so my answer is going to be negative infinity. Now, I might want to justify this. So again, I didn't make a table, I didn't make a graph, so I might say, or maybe as, okay, as x approaches pi from the right, all sine values will be negative, since the numerator is a constant, and always positive. We have a positive divided by negative, so our f of x is going to negative infinity. Now I want to emphasize, this is the key here is I want to know how you got there. So I know I said make a table, make a graph. A verbal explanation is fine, right? I knew that the denominator is 0. I knew there was a vertical asymptote at this point, right? So the only question I really had was, is this thing going up, right? Is this thing going up and up forever and ever, or is it going down and down forever and ever? I know, I'm using this as a coordinate grid and not in a unit circle. That's fine, okay? So is it going to positive infinity or negative infinity? And I said, hey, look, this is a positive. This is always negative. So if this is always negative and it's going to infinity, then it's got to be going to negative infinity. That's my description. If you're like, oh man, I hate that. That's not, who wants to do that? Then make a table. That's absolutely fine. Go and make a table. Okay? This is just what I chose to do. Okay, that was A, 3A. Let's go to 3B. Uh-oh, what is going on here? There we are. My pen may be running out. Let's see what we got here. I am running low. Let's see. Am I ready? Am I really running low? No, I'm not running low. Okay. That was weird. Okay, so let's look at 3b. What do we got? So we have the limit as x approaches 1 from the left of this function. Okay, so first off, I'm going to plug 1 in and see what happens. In this case, I get 1 minus 1 in the denominator. That's 0. In the numerator, I'm going to get 1 plus 2 plus 1. So I'm going to get 4 over 0. So this isn't indeterminate. So this tells me that there is going to be an issue. There is going to be a non-removable. If it has to be indeterminate for there to be a removable factor. But if you're not seeing that, that's fine, right? Let's factor it. If you're like, oh no, I don't believe you. Well, I mean, first off, you should believe me. Rude. But the numerator is x squared plus 1, which can't be factored, right? So there is no factor here. So now really the question becomes, as I approach 1 from the left, what's going on here? So this might be, again, one of those places where you want to make a table, right? You can plug in. If I were making a table here, I might plug in, let's see, x, f of x. So we're approaching, what are we approaching? We're approaching 1. So maybe I go 0.9, 0.99, 0.999. We're only approaching it from the left, right? So I could go and see what's going on there. Just a quick note, though. Before I go and do that, right, which is fine, I want to emphasize, please, I know I keep on saying this, please feel free to make a table. But I could also just think about this just like I did the last one. Every value that I'm plugging in is less than 1, right? Oops, I'm writing on this. This is less than 1. Well, the numerator, because it's squared, is always positive. This x is some number less than 1, minus 1. So the bottom is going to be a negative. It's going to be a positive I by a negative. So again, this thing is going to negative infinity. Just if I just think about it, right? If I just go through and think about it, I will see that. But if you're not comfortable with that, then we could always what could we always do? We could always just make a table. So let's go and make a quick table here. Let's see if I can do that. I don't have a graphing calculator here, but I do have decimal splits on my phone, so it's going to be a little slow. Let's see what we got here. So x squared plus, whoa, not happy. What are we going to do here? Yeah, this is why I don't want to do it on my phone, because I'm slow on my phone. You guys are probably already got it typed in. Again, I know it's going to negative infinity, and I would probably just justify it like I did the last one, but I know you guys might not. Let's go and do it, making a table real quick. 2x plus 1 over, what do we got? X minus 1. So in this case, if I plug in, what did I say? I'm going to plug in 0.9. If I plug in 0.9, I get negative 36.1. What if I plug in 0.99? I'm going to need more room, huh? Let's go do this. Let's go do this down here. Because I wasn't originally doing this. Let's planning on making a table. X. So I'm going to plug in 0.9, 0.99, and 0.999. So it looks like I'm getting, the first one we got negative 36.1. The next one was negative 396.01. If I wanted to do one more, be negative 3,996.001. So it's clearly going to negative infinity, right? Just like I said it would. Okay, not to say I told you so, but I told you so. Okay, let's continue. Man, that's some ugly handwriting. Is this 3? No, this is 4. Let's go to 4a. So for 4a, the question is, what type of discontinuity do we have? Okay, and where are these discontinuities? Assuming maybe these things are continuous everywhere. So let's look at the first one. I wonder if I should change that. I shouldn't. I wanted to do something with it originally. And so I'll bring it up what I wanted to do, but I've already done this, so I'm not going to change it now. But let's see what we got. So it's the denominator that I really kind of care about. In this case, I can factor out an x, and that gives me x squared plus 4. Now be careful. Okay, so in this case, right, there is a vertical asymptote at x equals 0 because I can't cancel out the x from top and bottom. There's nothing going on here, right? X squared plus 4 can never equal 0, right? No matter what you plug in x squared, you're never going to get negative 4. So all I can say is there is a non-removable discontinuity at x equals 0, right? I can't cross it out from top and bottom. Now, I want to point something out really quickly. This was kind of what I had originally meant to do. It's not a big deal, but I'd kind of meant to do something like this. I'd meant to write this as a 4. So it was x squared minus 4. And the reason is I wanted to kind of trick you guys. Hopefully you wouldn't have fallen into it. But I wanted to say, right, this becomes x plus 2, x minus 2 in the numerator, and the denominator is still this. I wanted you guys to still recognize this can't be factored, right? This cannot be factored, so there's no way to cancel out something from top and bottom here. Be careful, right? This cannot be factored. And the reason you can tell is if I set it equal to 0, I get an imaginary number, so it cannot be factored. So hopefully you guys saw that. Let's keep on going. That was that one. Let's go to B. Let's go to 4B. What do we got with 4B? So same question. Let me just make sure I answered the first question. It says determine whether the function below, where the functions below are not continuous. So non-removable at x equals 0. Okay, I answered it. Just making sure. Don't want to not answer it. So let's do this one. Okay. So let's just check. So my suspicion, I think you guys would agree, if there's going to be an issue, it's going to occur at -2. So let me just see what's going on at -2 real quickly. If I were to do direct substitution at -2, I'm going to just do this in orange, just kind of off to the side. So if I plug in -2 plus 2 in the denominator is 0. If I plug in -2 in the numerator, I get 4 times 4, which is 16, plus 7 times 2, which is -2, right? I said plugging in -2, so this would be -14 plus -14 minus 2. So it looks like it's going to be 0 over 0. So it looks like it's going to be indeterminate. Because it's indeterminate, I should be able to cancel out something from top and bottom. Let's find out if that is true. So in this case, what are we going to get here? How does this factor? Let's go with 4x positive 2x minus 1. Is that how that works? Let's see. 8x. Yeah, that looks good. So in this case, I think you guys would agree, right? The x plus 2's cancel out. So there is a removable discontinuity at x equals -2. Okay, let's keep on going. Let's keep on going. I feel like I can finish this. No, let's go through 5. Let's finish up 5. And then I will put a pause on it. L'Hôpital's always takes a little longer. They're not hard, but they always take a little longer. So let's do 5A. So 5a is asking if there's an x-intercept in each of these intervals. So for 5a, I want to know, is there an x-intercept between 1 and 2 for that function? So let's see. Well, in order to do that, the first thing I'm going to do is say, what is f of 1? Well, f of 1 is 1/12 times 1 to the 4th minus 1 cubed plus 4. So what is that? That's going to be a positive number. I don't know what that number is, but I mean, right, this is 1/12 minus 1 plus 4. I mean, that's a positive number. Again, I don't know what it is, but if you guys don't mind, all I really care is that it's positive. Okay? And we'll see why in just a second. Let's plug in f of 2. So f of 2 equals 1/12. 2 to the 4th is 16. So if you guys don't mind, I'll plug in 16. 2 to the 3rd is 8 plus 4. So in this case, what do we get here? 16 over 12. Negative 8 plus 4 is negative 4. I think you guys would agree, right? This, I don't know what this value is, but it's negative. So what does that tell me? Well, there's got to be an x-intercept between, so if you were to just kind of make a little graph here, right? So let's say between 1 and 2. Well, if at 1, the graph is positive, and at 2, the graph is negative, and we know that's a polynomial function, so we know this function is continuous somewhere, at least once on this interval, there's got to be a place where it crosses the x-axis. So let's put that together formally. So again, I'm going to say f of 1. Actually, let's do this. F of 2 is less than or equal to, let me move this down. Let me give myself a little room there. F of 2 is less than or equal to 0, which is less than or equal to f of 1. Remember, I'm saying 0, right? The k value in this case is 0 because they were asking where is the x-intercept? What is the y value of the x-intercept? It is 0. So in this case, the k is 0. So I've established that 0 is in between those two numbers, and then I can say f of x is a polynomial, therefore continuous on, what is it, 1, 2. And remember, it's a polynomial, so polynomials are continuous everywhere, but it is specifically continuous on 1 to 2. Okay, I've established that I can use the intermediate value theorem at this point, because those are the only two things I had to establish. I had to establish this, and I had to establish continuity on the interval. So I'm done with that. So now, conclusion. Conclusion. What is my conclusion? So I can say, by the intermediate value theorem, name the theorem. Please name the theorem. Don't be one of those people who doesn't name the theorem. You've got to name the theorem, okay? So by the intermediate value theorem, there must exist a C. Where is this? Now remember, this C is a domain value, right? So where is this domain value? Where is this x value? It's on the interval from 1 to 2, such that, what's special about it? Well, f of c equals 0. It equals that height value that we were looking for. Okay? Let's do 5b. Let's do 5b. Okay, so for this one, I'm going to do the same thing. Notice it's x cubed minus 5x. It's a polynomial. It's going to be continuous everywhere. So really, I'm just going to start with what is f of negative 3? Well, f of negative 3 is negative 3 cubed is negative 27. And this is going to be negative 5 times negative 3. So this is going to be negative 27 plus 15. That's a negative number, right? That is, what is that, negative 12? Okay, what is f of 1? Well, f of 1 in this case is 1 minus 5 times 1. So it is negative 1 minus 5 is negative 4. Notice, I'm going to be able to make a conclusion right here. I'm looking to see, is there an x-intercept in this interval? Well, I think you guys would agree this is false, right? This is absolutely false. 0 is not between these two outputs. That's a false statement. So there might be, right? It may be the graph crosses the x-axis on that interval, but intermediate value theorem doesn't tell me that. So all I can say is intermediate value theorem does not apply. Make sure you show why. So in this case, I'm kind of saying, hey, look, this is false. It doesn't apply. Make sure you say why. But in this case, it doesn't apply. Okay, I want to do 6, and then I'm going to pause this just because I want to get through all the intermediate value theorems. Let's do 6. Okay, what do we got here? We are trying to see if there's a C on the interval. I didn't give an interval. I did not give an interval. So I'm going to pause the video here so I can go figure out an interval. So we'll come back to number 6 and then finish it up in the next video. I will see you all then.